Good afternoon, everybody. So, first of all, thanks very much for CHIP for inviting me in this tremendous meeting. So, I've no clear, it's still an unsolved question. Do type 1 interferons play a role in DADA2 patients? And I'd like to show some clues or parallel between type 1 interferonopathies and the DADA2 story. So this is the overview. Let's start with what is an interferon. So it's known for a long time. It was described and identified initially in 1957 by Isaacs and Lindemann with a very nice experiments. They treated influenza, treated influenza, inactivated influenza, and put it on some chick egg cells, and they demonstrated that inside the supernatant there was something that you could transfer to another cells that would be protected from another infection. So this molecule, feeling that they are interacting with the immune system and with the viral infection, were called the interferon. And to date, so 3 different families of interferon have been described. And 60 years later, we have things slightly more complicated in this picture with a lot of color bricks, very hard to understand. But basically, still, there is some pathogen or viruses that can trigger the cell and being responsible for the interferon production that will play an autocrine and paracrine role then to transduce the signal through IFNAR1, IFNAR2 receptor and make the transcription of the interferon-stimulated genes. So the interferonopathies, this is a new field of disease associated to a dysregulation of type 1 interferon. And this disease, I don't know how much you are familiar with, started the story in 1984. It was described by 2 neuropediatricians in the Neckers group with a familial encephalopathy with calcification, basal ganglia, chronic meningitis, and it mimics a congenital infection. These patients were born with the calcification, Sézary encephalopathy, but every test for an infection, rubella, toxoplasmos, and so on, were all negative, and they predict that it could be familial, so there should be a genetic basis to this disease. So 4 years later, it was shown that type 1 interferon alpha, was increased in the CSF of this patient. And for a long time, it was a method to do the diagnosis in this patient. There is no evidence of any infection. It looks like an infection, congenital infection, and there is an increase of type 1 interferon in the CSF. And it took time to, in 2006, identify the first gene involved in this peculiar phenotype, the so-called type 1 interferonopathy that have been identified by Yannick Crowe. And it turns out that actually the phenotype is extremely broad. It can be the typical AGS phenotype with encephalopathy, early onset, to some less severe things, including recurrent stroke, including skin lesions that are, in some extent, reminiscent of what we can see in DADA2 patients. So all the genes, there are 7 genes known in the AGS patients so far. All the genes are related to the nucleic acid metabolism or signaling. And well, some of them, especially ADAR1, it's an adenosine deaminase restricted to RNA, to double-strand RNA involved in post-transcriptional modification. So what's the pathogenesis of this type 1 interferonopathy and how it can be linked to the DADA2 story? So this is a cell. Most of the cells are equipped by a system capable to sensitize, to recognize some DNA or RNA inside the cytoplasm. This is a virtuous system that protects us from any viral infection. And when you have this sort of DNA, RNA inside the cytoplasm, there will be a sensing and a production of type 1 interferon, and then a stimulation of the receptor and the induction of interferon-stimulated genes. But maybe you're less aware of this point. We can, all of us, produce some endogenous RNA DNA that will cross from the nucleus to the cytoplasm, and they could be detected by this innate sensor. we have negative regulators, which are this kind of enzyme that are able to cut this DNA, RNA crossing the cytoplasm and make them hidden from the innate sensor and do not imply any response of the immune system. And in AGS, actually, there is mutation in this enzyme. There is an increase of this endogenous DNA, RNA that will be detected by the innate immune system saying, well, we are infected, there is a current infection, we need to produce a lot of interferon. And this is what happened in the type 1 interferonopathies, and some of the enzyme again, especially ADA1, is an adenosine deaminase. So I'd like now to make a parallel with one of the type 1 interferonopathies, which I think is the main differential diagnosis for the DADA2 patient, which is a SAMG1 deficiency. So this is an Aicardi-Goutieres syndrome with a broad spectrum of symptoms, but it includes some neurological phenotype, and it's the only one to present this sort of vessel or vasculitis of the brain. And this is a report by Yannick Crowe in 5 patients, and you can see in some T2 weight MRI here some stroke of the occipital lobe. Here there is some right medium, right anterior and left anterior cerebral arteries that have been affected by a stroke. Here is some MRI images of these numerous collaterals, so-called Moya phenotype. Here is some various stenosis of the Willis polygon, and again in another patient with a conventional angiography, we can see some aneurysm here, here, that are very similar to what can be seen in the DADA2 patient. So in this patient, it starts early in life. As for DADA2, there are disabling disease. There is various neurological symptoms with stenosis, collaterals, and aneurysm. And it's severe. 2 of them died early in life. So there is skin lesions still in type 1 interferonopathies. Some of them are quite specific. I would say this child-brain aspect occurring in the winter. But there is also some vasculitis of the extremities, sometimes some amputation with very severe lesion reminiscent with what can be seen in polyarthritis nodosa. So there is, and it was mentioned this morning by Marco, there is a way to explore, to suspect this disease, which is doing the interferon signature. What is interferon signature? You take some whole blood and you can analyze 6 transcripts that are upregulated in the condition of type 1 interferonopathies. Actually, it's very hard to catch the protein itself, so we look at the ISG. And it's extremely important to discriminate the patients from the controls, and here is a picture with SAMG1 patients. So what about DADA2 and our modest experience in these patients? We had to investigate this family first, the European ancestry, no consanguineous union, and it started with the older brother who presented with recurrent stroke from the very early onset, and he had also a kind of long-lasting inflammatory disease, and he died at the age of 28 of a new recurrent stroke. The youngest here was the patient 1 in the study, and he presented pretty the same kind of symptoms with a very severe neurological involvement, recurrent stroke, fever, recurrent fever from the very beginning of the life, this livedo lesion in the skin, and some immunodeficiencies, anomalies, just biological anomalies with a low IgG, low IgM. This is the picture of the MRA, here with an hemorrhagic lesion. Here is an ischemic attack and some stenosis on the MRA. Very similar to what can be seen in SAMG1 patient, actually. So this is a second family, who was seen in Birmingham by Evangeline Wasmer and Marlene Cartwill, who's in the audience. And it's a young boy born from a consanguineous union. And he presented again with the dactylitis, fever, erythema nodosum, so maybe more reminiscent of the polyarthritis nodosa phenotype, headache, and some recurrent stroke that make the DAD2 compatible with. So we performed genetic studies. We were aware of these stories a very few weeks after the presentation at the press meeting a few years ago of this new disease. So we sequenced CSR1 in these two families, and we identified in the patient 2 an homozygous B allelic mutation in the Georgian variant. And in the patient 1, we find an ET compounds mutation. One was already known, and the other one was likely pathogenic on the different scores. And in patient 1, we checked that ADA2 was indeed decreased for the activity. So just to keep going with the possible common things between these two diseases, we performed some transcriptome analysis. And this is the interferon signature done in a patient. So in blue color, there is the controls. In green, it's the patient 1. In pink, the patient 2. And we added 2 patients with SAMHD1 mutation just to compare. And it has been done several times. That's why we have 2 in green and 3 in pink here. And compared to the control, in all these patients, several times, there is an increase of type 1 interferon signature. It's not as higher in the SAMHD1 patient, but there is, and it was consistent. This patient never received, at the time of the sampling, etanercept. So then, we perform an unbiased genome-wide array to detect what was shared by the AGS patient and the ADA2 patients, and what was different. And we, regarding the top I upregulated transcript that were common in these 4 patients, we identify most of the interferon-stimulated genes. Again, feeling that there is maybe some common point in between these 2 pathologies. And there were also some differences, and among the highest expressed and different transcript between ADA2 and AGS, there were all this set of genes reported to be a neutrophil signature. And we find by FACS also that there were, some of them were overexpressed, and especially the myeloperoxidase, which suggests that there is an activation of the neutrophils as well in these patients. So the comparison in between a type 1 interferonopathy and DADA2, regarding the neurological symptoms, it's very hard to say how much it could be different. I'm not a neurologist, but I think it's pretty the same sort of things. Regarding the skin, the childbline is more specific from SAMHD1 mutation, but the libido of the DADA2, they all can get some positive autoimmune markers, but the immunodeficiency is specific from ADA2. And interferon signature was increased in both situations, and not the neutrophil signature. So then we had the opportunity to investigate a new family. With the presentation was more something like the immunodeficiency phenotype, starting with the lymphopenia, low IgG, and neurological symptoms. Often, I didn't mention, it's often triggered by a viral infection, and it's also similar in SAMHD1 patients. So it started with an encephalopathy, maybe triggered by an infection, meningitis, and a stroke. And the sister presented with the same sort of things, with a nerve palsy, and it was evocated that they are an DADA2. And indeed, it was an ET compound mutation in just here, and then the next question was always the interferon signature. And regarding the interferon signature compared to control, here is the first sister, the second sister, assessed several times. So here is the interferon signature, slightly increased maybe in one sister, but normal in the second one. Both were treated with etanercept, and it's pretty like what you presented this morning. So under treatment, there is a discrepancy, and it can't be explained by the phenotype, so we have no idea why it's happened. And the neutrophil signature was negative in both patients. So just as a conclusion, I think that the question is still open. It's quite striking to see that there is some things very similar in the 2 situations. The adenosine and deoxyadenosine that are in excess might trigger an interferon production, but there is a missing link. We don't know how does it work, and I know that in the next abstract during the afternoon there will be a presentation showing that ADA2 could be expressed also in lysosome. I don't know if endosomal TLR, or if there is a role in this signaling of extracellular nuclear DNA, RNA, etc. And well, the loop is still to be investigated, how the TNF can modulate all these sort of things. Well, question is still open. I mean, thank you very much.